In this video, we're going to look at the example: a rocket is initially at rest on the launch pad. After launch in the positive y direction, the rocket travels at 75 meters per second at an altitude of 1 kilometer. What is the constant acceleration caused by the rocket? Alright, so let's go back to the problem. It says initially at rest, so that tells me my initial velocity is 0 meters per second. And then at some other point, the rocket is traveling at 75 meters per second. And that 75 meters per second corresponds to the rocket being 1 kilometer above the ground. So the 75 meters per second is the final velocity, and our displacement is the 1 kilometer. And it asks what the constant acceleration is. That tells us we need to use our kinematic equations, and then over here we're solving for our acceleration. Since we're not given time in the problem, I want to use my one kinematic equation, velocity squared equals velocity initial squared plus 2 times acceleration times displacement. I want to use that equation. So I plugged in here for the final velocity the 75 meters per second. For the initial velocity, I plugged in the 0. Acceleration is our unknown. And then, since we always need to be in SI units, I converted the 1 kilometer into meters. So I plugged in the 1,000 meters. So let's expand on our math a little bit here. 75 squared is 5.625 times 10 to the 3. And because we squared the number, we also squared the units. So the units become meters squared per second squared. 0 is just 0, so we don't have to worry about it. And that's going to then equal 2,000 meters times the unknown acceleration. So I'm going to divide both sides by 2,000. And that is where I get the 2.8. Let's look at the units though. I have meters per squared per second squared divided by a meter. So I'm going to multiply and flip the second fraction. That means this meter here cancels out and one of the meters up top canceled out, which is where I get the units in meters per second squared.